Hi everybody, how are you doing today? It's Kevin here with our last section of Chapter 6. Thank goodness, eh? I know that the last two sections have been a little tough, a little bit tougher. You guys have done a really good job. You really have. Just keep going. We only have like 7 more weeks of school left. And then you can, oh, you're home anyway. Anyway, school will be over. And then hopefully things will start getting back to normal. But you guys just keep doing what you're doing, you know. Just keep on working. You guys are doing good. Now, even though those last two sections were a little odd and a little challenging at times, they're all coming down to one idea, and that's how we solve equations. Every time we reduce or simplify, it's all to solve an equation. Now, some of the crazy simplifications that we've done in the last two sections, you won't really use them to solve anything crazy until next year in pre-calc or college algebra. So what we're going to do in this section is going to be what I need you to know how to do for solving equations. And we're going to have equations that have radical expressions like this. The square root of 8, the square root of x equals 8. Well, you can figure that out already most likely. I'm guessing you already know that 64 will be your answer because the square root of 64 is 8. Now, if we're going to show work on this, the opposite of a square root is a square. So the square of square root becomes x, and 8 squared is 64. Now that's your answer. Now I have to give you a little warning, just a little, because some of you might be thinking, well, what about negative? Isn't square root sometimes negatives and things like that? Remember the definition, the square root of a number is always the positive. Right? The square root of 64 is 8. So what you really have to do, though, unlike other equations, where you know how we always say check your answer to make sure it works? Well, we're going to say it again, but this time it's going to be a little bit more important. Check your answer to make sure it's correct. You might get an answer, and all your algebra is perfect, but doesn't work. And you'll see 2 examples of that. Okay? Now let's kind of move on here. Solving equation. You know how to solve equations. My goodness, you've been doing this for a long time. So subtract 3 from both sides, and you get 7. The only difference now is you have a radical. Well, it's a square root. Well, how do you undo a square root? You square. So the square root of 2p squared is 2p. 7 squared is 49. Divide both sides by 2. That's most likely our answer, but let's check it out. So if I multiply this out, those cancel. It's 49. The square root of 49 we know is 7. And we know, we've known that for a while, that 7 plus 3 is 10. That is our answer, and it works. Okay? These equations aren't so bad. Oh, it's to the 1/2 power. Well, you guys know that means a square root, but I want to show you how to solve it when it's as a rational exponent. So we're still going to subtract 6 from both sides. Now the variable is isolated. What can I raise it to? Now if it was a square root, you'd say we'd square it. Well, you see how it's still the same? Because when I raise a power to another power, I multiply those powers. And what's 1/2 times 2? Or what's half of 2? It's 1. So we don't eliminate the exponent. We change it into something that's nice. It's c to the first power. Well, anything to the first power is itself. That was our goal. If you think about it, the 1/2, it's the reciprocal that gives us 1. What's 1/2 flipped over? Well, it's 2 over 1. That's what we use. All right, this is probably correct, but let's just check. What's 9 to the 1/2 power? Well, it's the square root of 9, which is 3. 3 plus 6 is definitely 9. This definitely is our answer. Okay, now you've dealt with radicals and rational exponents. Now we've got another radical, but it's a cube root. That's okay. Cubes. are the inverse of a cube root. The cube root and the cube, they don't eliminate each other. Well, they do, kind of. What do they become? What do they transform into? Well, remember how you write these? It's 3 over 3. 3 over 3 is 1. It transforms itself into 1. That's why we don't bother. That's why we say, hey, it's simplified because it becomes 1. And what's 7 cubed? 343. I only remember that because in one of the previous sections we did that. All right, subtract 2 from both sides. 341, probably true. Let's check it out. 341 plus 2 is 343. Is the square root of 340, I'm sorry, the cube root of 343 equal to 7? It is. This is correct. All right. Another similar problem, another cube root. Let's do this first. Subtract 6 from both sides. 9 minus 6 is 3. It's a cube root. We cube. These cubes transform into 1. This cube you use, 3 cubed is 27. Add 4 to both sides. We get 31. Again, probably the right answer. Let's double check. 31 minus 4 equals 9. That's 27. Now what's the cube root of 27? It's 3. This is correct. This works. There we go. Solving equations. All right. Square root again. Let's do it. Subtract 3 from both sides. So I get 2m minus 6 equals negative 3. What's the opposite of a square? Root, I mean, we square. 2m minus 6. Negative 3 squared. Be careful. Negative times a negative is a positive. All right. Add 6 to both sides. And what do we get there? If I add 6, I get 15. And divide by 2. Half of 15, 15 halves. Or 7 1/2 if you feel like it. All right, let's check this thing. 2 times 15 halves minus 6 plus 3 equals 0. These cancel. 15 minus 6 is 9. Square root of 9 is 3. And that's not true. 6 does not equal 0. What did we do wrong? We did nothing wrong algebraically. Nothing. I told you sometimes the answers actually don't work. 15 over 2 is not going to be an answer. This equation has no solution. Now can you see why? Where the danger comes in? The danger was here. When I subtracted 3 from both sides, I have a negative now. And when you square a negative, it becomes positive, which means you kind of lost a negative. We call it an extraneous answer. The answer didn't make any sense. Now, when you guys get to pre-calc or college algebra, you're going to be dealing with equations that have multiple answers. They might have 2 or 3 answers, of which only 1 might work, or 2 might work, or all 3 might work. You don't know. You have to check your answers. That doesn't happen very often. But the idea is that sometimes your algebra is not flawed. It's just you introduce a number that makes the whole thing invalid. As soon as that became negative, and as soon as I squared it and got rid of that negative, this was doomed for failure. Doomed. Okay, so make sure you always check your answers. How about this one? Will this be okay? I'm going to add 1 to both sides. You might be thinking, hey, there's not a negative here. I should be fine. We'll square it because that's the opposite of a square root. We get 9. Going to add 5 to both sides. We get 14. 14/8. I will reduce that to 7/4 and see if that works. So 8 divided by 4 is 2. 2 times 7 is 14. 14 minus 5 is 9. Okay, that's all right. That checks out. This is an answer. Okay. Oh, I need to put the positive 6. We'll probably be okay. We haven't thrown in and created any negatives. So square both sides. I just made that worse, didn't I? I'm going to take that and do that one again. Here we go. All right. The root and the square cancel each other out. 6 squared is 36. Subtract 5. Half of 31. Okay, if you write 15.5, that's totally up to you. Check it. These cancel. 31 plus 5 is 36. Square root of 36 is 6. This is true, which means this is your answer. Okay, a few more for our equations. To the 1/2 power, no problem. First, we'll add 6 to both sides. Now remember, what do we raise the 1/2 to get rid of it? Well, the reciprocal. We want it to be 1. So 1/2 times what would give us 1? We'll take 1/2 and flip it over. We get 2 over 1. Now I'm not going to put 2 over 1 because 2 over 1 is just 2. But what's 1/2 times 2? Well, it's 1. We've not eliminated it, but changed it into a 1, which is very helpful to us because it doesn't change the answer. 3g plus 1 is 100, so I subtract 1 from both sides and divide by 3. 99 divided by 3 is 33. Will it work? I didn't see anything crazy happening with roots, so I think we're okay. 3 times 33 is 99. 99 plus 1 is 100. 100 to the 1/2 power is the square root of 100, which is 10. That's correct. That's true. Good. All right. Oh, a 2/3. Well, I'm going to give myself a little room here. But it's no different. What power do I raise it to eliminate a 2/3? What's its reciprocal? Do that to both sides. 3 over 2. Because when I multiply 2/3 times 3 over 2, what do I get? 6 over 6, which is 1. I've turned it into a 1, which makes me happy. Now I got to calculate this. Don't forget, an irrational exponent, the power and the root. So what's the root of 9? The square root of 9 is 3. What's 3 to the 3rd power? Is 27. All right, subtract 5. Divide by 2. Is 11 going to work out? Let's find out. 2 times 11 is 22. 22 plus 5 is 27. Is this true? Well, you might think if I get from here to here, it's got to be true. The cube root, since the 3 is the denominator, the cube root of 27 is 3. 3 squared is 9. This is true. That works. All right, subtract 4. How do I undo a 1/4 power? What's its reciprocal? 4 over 1, or 4, because 1/4 times 4 would be 1. Negative 2 to the 4th power. Remember, 4 negatives becomes a positive. Add 5 to both sides. Divide by 3. And let's check our answer. (21 minus 5 is 16). The fourth root of 16 is 2, because 2 times 2 times 2 times 2 is 16. And we get this, which is not true. 3 does not give us an answer. It has no solution. All right. Some of you saw it, didn't you? Some of you saw it early on. You saw, we have a negative, and we're taking that negative to an even power, which means we eliminate the negative. And once we've eliminated the negative, we run into trouble. And we did. We came into an equation, or a solution that was algebraically perfect, but did not yield us a correct answer. Tried to sneak it past you guys. Did I fool you? Did I fool you? Maybe. Probably not. All right, 2 more for this video. We're square rooting both sides, so we'll just undo it. We'll square both sides. We end up with this. Looks good. Solve like normal. Subtract a d from both sides. Get d minus 5 equals -1. Add 5 to both sides. Get d equals 4. Let's see, does that work? 2 times 4 minus 5. 4 minus 1. 8. 8 minus 5 is 3. 4 minus 1 is 3. Guess what? It's not a whole number, but doesn't the square root of 3 equal to square root of 3? Yeah, it does. And we're okay. One more. We'll square them again. 2x plus 5 equals 2x plus 1. Well, that seems weird. Some of you might be noticing already what's happening here. If I subtract 2x from both sides, I've eliminated all the x's. I end up with that. Well, guess what? 5 doesn't equal 1. Not in our base 10 number system. 5 does not equal 1, so guess what? No solution. So you always either need to check your answer or you run into an impossible situation. And don't think you did it wrong. Most people think if they end up with something like that, they did something wrong. No, trust your math. You're good at it. Do your algebra. If it doesn't work out, guess what? There's no answer. Okay? All right, so that does it for this video. In our other video on this last section, we're going to be solving radical inequalities. Exciting. All right, until then, bye.